we will continue talking about ways to conduct hypothesis testing today. We previously discussed looking at t-statistics compared to t-critical values to make a decision about our null hypothesis. But this actually isn't the most common method for making decisions about the null. The most common method includes evaluating p-values. What are p-values? They are the probability of attaining your t-statistic or a value more extreme than your statistic, assuming the null hypothesis is true. If you remember, we used this probability terminology before when discussing our z-scores. So with p-values, just like with z-score probabilities, these refer to areas in the distribution. Specifically, a p-value is the area beyond or more extreme than the t-statistic we calculated from our sample. It will be the area from our t-statistic out towards the tails, similar to how we shaded before from our critical values out towards the tails for our rejection region. Now, why does the definition state that this is the area assuming the null is true? Well, remember, we start with a claim, like mu equals 307 in our tower example. If the null is true and the population mean really equals 307, then just as we learned with sampling distributions, I would expect that most of the samples I could collect from the population would have means centered around 307. We could expect a sample mean reasonably close to 307 for 95% of the samples we could obtain if the null was true and the population mean really is 307. This is why if we find a t-statistic that's not far out in the tails, we fail to reject the null. This is what we expected if the null was true. Let's go back to this picture. Here we have a t-statistic of 2.5. What does that mean? Well, it means our t-statistic was unlikely for us to get if the null were true. Therefore, we have evidence that the null likely isn't true in our population. It says that we instead have evidence that our sample came from a distribution which is centered around another value. We always believe our sample mean was something that was likely to be obtained. But in order for a sample mean out in the tails to have been a likely value to obtain, it would have had to come from a distribution centered around a value other than 307. This is why we then conclude we can reject the null hypothesis in these cases. Now, let's go back to our test from last time. We determined that with a t-statistic of 1.80 compared to our critical value of 1.99, that we would fail to reject the null hypothesis. We can confirm that decision as well by calculating a p-value for our test statistic of 1.80. P-values can only be calculated with technology and are found by first calculating the t-statistic for our sample, then using that and the degrees of freedom to calculate the area beyond our t-statistic. For our t-statistic, we get a value of 0.075 for our p-value. That means we expect that 7.5% of all t-statistics are as or more extreme than our t-statistic, or that the red area on this chart marks off 7.5% of the distribution. When we fail to reject the null hypothesis based on our t-critical being less extreme than our t-statistic, we will also find our p-value will always be more than 0.05. Why? Well, remember, we set our t-critical to purposely mark off the most extreme 5% of our distribution. We call this 5%, or value of 0.05, our alpha level. It's the area we set as our rejection region. So, if our t-statistic does not fall beyond the t-critical in the tail, then when we shade from our t-statistic out towards the tails, we will shade more than 5% of the distribution. Notice the red area of our p-value is bigger than the blue area was in our rejection region. Conversely, if we have a t-statistic beyond our t-critical in the tail, we will reject the null hypothesis and find a p-value less than 0.05. Because now we have moved beyond the point that marks off the 5% area. So only a smaller area than that can be shaded, and therefore we will get a smaller p-value than 0.05. Now, here's a tricky truth to remember about a p-value. It is not how likely you think the alternate hypothesis is to be true. Instead, it's how likely you think your result would have been if the null were true. Other key takeaways about p-values and alpha. Both p-values and our alpha level refer to areas. Alpha is something we typically set to 5%, and we use this standard for all samples and tests. A p-value is something we calculate for each sample after obtaining our t-statistic. The relationship between our p-value and alpha is that if our p-value is less than or equal to alpha, we know we can reject the null hypothesis for any test. For a p-value more than 0.05, we will fail to reject the null hypothesis, as this is a value we would expect if the null were true. We will use p-values for every statistical test we do in this class. While the calculation of the test statistics will vary, the conclusions we make based on our p-values will always be the same.